Hello everyone. Is my voice clear to all? And also my screen is visible clearly or not? Let me know in the chat box, everyone. Can you please? Okay. ठीक है. Okay. So shall I start? Okay. So good afternoon to all. And today we are going to start our new chapter, that is differential equation. Okay. So in this session, we are going to cover types of differential equations, order and degree of differential equation, solution of the differential equation, formation of differential equation, method of solving first order differential equations, and variable separable methods, homogeneous methods. Okay. So all these concepts or all these portions we are going to cover in this session. So let's start with the introduction. Okay. So what is differential equation? Right. So actually a differential equation involving the derivative, and with it is an equation. That must be an equation with derivative. Like here you have some examples you can take. Dy by dx is equal to 0, sine of dy by dx plus cos x is equal to 0. So these are some examples of differential equations. So is it the differential equation? Is it the differential equation? No, it's not a differential equations, because this equation is not involving the derivatives. Clear? Okay. So let's move. Types of differential equation. Okay. So two types are there. One is ordinary differential equation and other one is partial differential equation. Okay. So in case of ordinary differential equation with derivative with respect to only one independent variable. Okay. So here in case of ordinary differential equations, we have only one independent variables. That means in dy by dx, x is my independent variable and y is my dependent variable. Yes or no? Dependent variable. Okay. So what do you mean by partial differential equation? That is derivative with respect to more than one independent variable. So you can observe here, we have more than one independent variables, that is x and y in this equation. So such type of equations are called partial differential equation. Got me? Okay. So let's move. Okay. Now we'll learn how to find the order of a differential equation. So order means the highest derivative present in the differential equations. Okay. So highest derivative present in the differential equations means, suppose we'll take a small example, dy by dx is equal to 4x. So what is the order of this differential equation? That is 1, because only we have differentiate y only once with respect to x. So how many times you are differentiating or your derivative is present, that is the order of the differential equation. You can see here also the second example, d square y by dx square plus 2 dy by dx is equal to 3x. It's a differential equation, but in this case the order is 2. Why? So because highest derivative is occurring here twice. That's why the order is 2. Okay. You can take another examples also. Here in this case order is 3 because d3y by dx3. Okay. So the different order of this differential equation is 3. In this case dy by dx is equal to x into ln of d square y by dx square. So order is 2 here also because d square y by dx square present. Is that clear? So in the third examples, you can observe here, order is 3 because the highest order derivative is 3 here, not 4, because 4 is the power of highest order derivative, right? So that's why the order is 3. Is note is mentioned here, order of a differential equation always a positive integer. Remember, order of a differential equation is always a positive integer. Clear? So now we learn how to find the degree of a differential equation. How we can find degree of a differential equation? That is the highest power of highest order derivative present in the differential equation. Okay, so in this case, oh, let's see, highest power of highest order derivative present in the differential equation. So you can check here. In the first example, d square y by dx square to the power 2 into 2 into dy by dx to the power 4. So the order is simple, that is 2. But what is the degree? So to find the degree, we should find first highest order derivative. So who is the highest order derivative present in the given differential equation? That is d square y by dx square. So what is the power of d square y by dx square? That is 2. So order degree is 2. Simple. Okay. So come to the second example, that is d square y by dx square to the power 4 by 3 is equal to dy by dx plus 4. Okay. So how, in this case, how we can find the order degree of the differential equations? Okay. So see, if we'll cube on both sides, if we'll take cube on both sides, so what will happen? I'm taking both sides as cube. Okay. So after taking cube on both sides, we are getting d square y by dx square whole to the power 4 is equal to dy by dx plus 4 to the power 3. So the degree becomes here 4 because the highest order derivative is d2y by dx2. Is that clear to everyone? Yes. So the important thing is the exponent of all the, always remember, when the degree of a differential equation can be defined, that is the exponents of all the differential coefficient. Exponents of all the differential coefficient should be free from radicals and fractions. It can be fraction or it can be radicals also. The power of the differential derivatives, right? So those are must be free of radicals and fractions. Radical means cube root. Yeah, इस type का. Okay. And second thing is the degree is always positive natural number. So degree always must be positive natural number. Okay. That is, you can say whole number. Oh. Positive natural numbers you can say. Okay. The third thing is the degree of the differential equation may or may not be exist. Okay. In some cases also degree of differential equation may not be exist. Okay. If there is radicals also. Okay. Like that. Sure. Let's see. Here you have a concept test. Find the order of and degree of this differential of the given differential equations. And for these questions, you have 1 minute. So let me know what is the answer of these questions, and your time starts now. Guys, solve fast. What is the answer? Yes, anyone got the answer? Please respond in the chat box. time to discuss your solution. Anyone got the answer? So what is the answer? Let's see. For the first question, you have this equation, and the power, the exponent of the highest order derivative must be positive natural number, but here we have fraction, right? Fractions. So first we need to delete that fraction. So how we can remove that fractions? How we can remove the fraction? By taking the power raised to 4 in both sides. Okay, so see here, when we are taking 4 on both sides as power, then it becomes y plus dy by dx to the power 6. Okay, so what is happening here? The order becomes 2. Already we know what is the order of this differential equation, that is 2. And what is the degree? Degree is the power of highest order derivative. That is d2y by dx2 is my highest order derivative, and the power becomes 4. Okay, is that everyone? Okay, you can take here. If you are taking, it is given, na? It is given already. That is clear. Okay, clear. So the degree is 4 and the order is 2. Okay. In the second example, second questions, what is happening? E to the power d cube by dx cube minus x d square by dx square plus y is equal to 0. So equation cannot be expressed as a polynomial in the differential coefficient. So degree is not applicable, but order is 3. Yes, order is 3, but it can't be expressed as a polynomial differential coefficient. So polynomial differential coefficient means it is present actually, so d3y by dx3, it is actually present in the power of e. Or if you have like that, sine of d3y by dx cube, it will also not be, degree can be defined. Degree can't be defined. So in the second questions, degree cannot be defined. Order is 3, but degree can be defined because it is present in the power of e. Okay, got it? So let's move. Now, how we can form a differential equation? Okay, so if you have a family of curves, differentiate the family of curves, the equation of family of curves, you will get a differential equations. Okay, suppose you have a family of curves and you will integrate it, also you will get a differential equation. So let's see. So what are the procedures, what are the steps to form a differential equation? That is, first step is differentiate the given equation with respect to independent variable. You know all these things, you know, or you have studied already all these things in your class also. These are the board concepts. Differentiate the given equation with respect to the independent variable. That means with respect to x, as many times as the number of independent arbitrary constant is in. Okay, so till when the arbitrary constants are removed, till then you have to differentiate that equation. Okay, so second thing is eliminate the arbitrary constant. You have to, by differentiating, you have to eliminate all the arbitrary constants. Then what you are getting, that is the differential equation. Simple. Okay, so let's move. What is the solution of a differential equation? So first thing is general solution. What is general solution? Solution involving arbitrary constant. That is, we can say y is equal to mx plus c. It's a solution of general solution of a differential equation. So what particular solutions? Particular solutions, that is solution free from arbitrary constants. Free from arbitrary constants. So that is y is equal to x plus 1. Here we don't have any arbitrary constants, but we have a constant 1, but not c. In this case, in place of c, you can take any constant. That's why it is called arbitrary constants. But here we have a constant only. We don't have any arbitrary constants. So in that case, we can say particular solution. Okay, is that clear to everyone? So let's move. Now, differential equations of first order and first degree. Okay, so differential equation of first order and first degree is of the type dy by dx plus f of xy is equal to 0, which can be also written as m dx plus n dy is equal to 0, where m and n are functions of f, x and y. Clear? You know all these things. Okay, so let's move. Now, solution of a differential equations will learn here. Now we are starting our method to solve the differential equations. The first method is variable separable method. Second is homogeneous equation method, how we can solve the homogeneous differential equations. Linear differential equations method also will learn how we can solve the linear differential equations also in this session. So let's start with variable separable method. Okay. Now for these questions you have 1 minute and try to solve it. Your time starts now, guys. Try to solve it. It's a very easy question. I hope all of you solve. Sorry guys, actually I'm facing some technical issues. Just I'm sharing again, no need to worry. I hope this is done. Everyone, I'm audible to all, guys. Everyone, I'm audible to all. Yes. Am I audible to all, guys? Okay. So let's solve this equation by using the variable separable method. So how we can? So we'll just separate the variables. How we can separate the variables? What we'll do? We'll take this y to this side and we'll take this x to this side. So that means 1 plus x upon x dx is equal to y minus 1 upon y dy. So now you can see here in the left hand sides what you have, that is with the variable x, and in the right hand side what you have, that is the variable with the variables in y. Now, if we'll simplify it, actually, what we are getting 1 plus x upon 1 plus 1 dx is equal to 1 minus 1 by y dy. So what is the next step to do? That is, you have to integrate on both sides. Okay. So by integrating, what you are getting? We are getting 1 by x, integration of 1 by x with respect to x, that is ln x, plus 1, integration of 1 is x, okay, plus c1, you can write c1, no problem, okay, is equal to y minus ln y plus c2. So see here what is happening. So if I'll take this to this side and c1 to the right side, so what will happen? So we are getting x minus y plus ln x minus ln y is equal to c2 minus c1, or we can, in place of c2 minus c1, we can write only 1 c, because it is constant. Okay, so x, what is your solution, becomes x minus y, and we know ln of x minus ln of y is, we can write ln of x upon y. Is that clear or not? Yes. So is equal to c. So this is the solution of the differential equations. I hope this is clear to everyone. I hope this is clear to everyone, guys. Let me know in the chat box. Is that clear to everyone? Clear? Okay, let's move to the next question. And see, you have a concept test for you, and for these questions, I'm giving you 1 minute only. Your time starts now. Try to solve it. Use the variable separable method and try to solve it. Done? Anyone is getting answer? You can share your answers in the chat box. Okay, so it's time. See, solve the differential equation x cube minus y square x cube into dy by dx plus y cube plus x square y cube is equal to 0. So first duty is, क्या करना है तुम्हें? What should you do first? So we need to separate both the two variables, both variables. Okay, so how we can separate these variables? Let's see what is the solution of this question. See, after what you will get, so from this you can take x cube as common. Okay, so if you will take x cube as common, so what you will get? 1 minus y square and upon y cube dy. After separating the variables, what is the equation you are getting? That is this: 1 minus y square upon y cube plus 1 plus x square upon x cube dx is equal to 0. So now what is the next step? So you have to now integrate. So integrate this. Okay, so after integrations, what you will get? 1 upon y cube, integration of 1 upon y cube is y to the power minus 3 if you use the power rule. So that will be 1 upon y square into 1 by 2. And also if you integrate 1 upon x cube. So what you will get? 1 upon x square. So from both this, we are taking 1 by 2 as common. So 1 by 2 into 1 plus y square plus 1 by x square. And from here, by integrating 1 by y, we are getting ln of y, and by integrating 1 plus 1 by x, you are getting ln x. So ln x minus ln y will be ln of x by 1. So this is your solution of the last exam of this examples concept test. Okay, I hope this is clear to everyone. If yes, you can respond in the chat box. Is that clear to everyone, guys? Clear? Shall I move? Okay. Let's solve another questions. Okay. Questions. Reducible variable separable method. Okay. Let's solve this question. So how we can solve it? So here the method is known as equation reducible variable separable method. So that means here you have to use a substitution to reduce to the variable separable form first, because in the argument of cos and sine, both the variables are present. So we cannot separate these variables without reducing it, without substituting it. Okay, so how you can solve it? How we can reduce to variable separable form? Tell me. Anyone? Okay, let's see how we can do it. If we'll put substituting x plus y is equal to t. So if we'll differentiate on both sides of this equation, what you will get? That is x differentiation is 1. Okay, y ka differentiation, that is y dy by dx, and t differentiation is dt upon dx. So dy by dx becomes dt upon dx minus 1. So in place of dy by dx, what we'll do, we'll write dt upon dx minus 1 and cos of x plus y. So we have taken already x plus y as t. Yes or no? So in place of x plus y, we'll write t. So cos t minus sin t. Now you can see, you can visualize, okay, it is easily come to the variable, reducible variable form. So that is variable form also, separable variable forms. Okay, so you can now substitute or you can separate all the variables. Dt upon 1 plus cos t minus sin t is equal to dx. After integrating, what you are getting, that is the solution. Clear to everyone, guys? Is that clear to everyone? Yes. So let's see. Now we'll learn what is homogeneous equation. First we'll learn what is homogeneous equation. So homogeneous equation is a function f of xy is said to be homogeneous function of degree n if the substitution x is equal to lambda x and y is equal to lambda y, and for lambda is greater than 0 produces the equality. Okay, leave this. So f of, if you have given a function that is f of xy, okay, so how you can check it is a homogeneous function or not? Just put, substitute x is equal to lambda x and y is equal to lambda. So after putting lambda x, lambda y in place of xy, so if you are getting such type of equation, then you can say it is a homogeneous equation with the degree n. Here n is called my degree. Clear? Chalo. Let's check whether the given function is a homogeneous function or not. Given function is a homogeneous function or not? Tell me. So what we'll do, we'll just substitute x is equal to lambda x and y is equal to lambda y. Okay, so after substituting, what we are getting, so f of lambda x lambda y becomes lambda x into lambda y upon lambda x plus lambda square y. Okay, lambda square y square. Okay, so from the numerator you can take lambda into x y, lambda square into xy you are getting, and in the denominator what you are getting, that is lambda x plus lambda square y square. So we are not able to bring this into this form. We are not able to bring the given function into this form. Okay, so that's why it is not a homogeneous function. You can say it is not a homogeneous function. Okay. Okay. In these examples, you can visualize here f of xy is equal to x square minus xy. So if you put here lambda x, lambda y, you can check lambda square x square minus lambda x, lambda y, that is lambda square x square, here lambda square xy, and after taking lambda square as common, what we are getting, x square minus xy. So see, lambda square into f of xy we are getting. So here it is a homogeneous equation and the degree is 2. It is a homogeneous equation and also the degree is 2. Okay, so this is the example of the homogeneous function, and this is not a homogeneous function. And now we'll learn homogeneous first order differential equation. What is it? Homogeneous first order differential equations. What is that? Yes. So a differential equation of the form dy by dx is equal to f of xy upon g of xy. And so in place of x and y also you have to take here lambda x, lambda y. Okay. So if f of xy and g of xy are homogeneous function of xy and of the same degree. Okay. Of the same degree said to be homogeneous, such equations can be solved by. Okay, so this is simple. Same degree means if you have dy by dx is equal to f of xy upon g of xy, so how you will check same degree means, that is if you put lambda x, lambda y here, okay, and g of lambda x, lambda y. So if you are getting lambda to the power n into f of xy upon lambda to the power n into f of xy. Okay, and this lambda to the power n, this lambda to the power n will be cancelled out, or we can say same degree. If f of xy and g of xy are two homogeneous functions of same degree, or we can say lambda degree must be 0. Okay, lambda to the power 0, that is without we can say also the degree of the same degree, we can write also of the degree 0, that is lambda to the power 0 into f of xy upon g of xy also. Is that clear? So how we can solve this type of equations? By substituting y is equal to vx, remember, so that dependent variable y changed to another variable b. Okay, so let's see an example here. Okay, solve this differential equation by using the homogeneous method. First check whether it is a homogeneous equation or not. Yes, it is a homogeneous equation. Okay, so let's solve this by substituting y is equal to vx, and you have, for this question you have 1 minute also, and your time starts now. Anyone got the answer? Okay, it's time. Let's solve. Huh? So see, the equation is the homogeneous equation of the degree 0. And what we'll do, put x is equal to vy, or you can take y is equal to vx also. Here we are putting x is equal to vy. Okay, so after differentiating, what you will get? So dx is equal to v dy plus y dv. After differentiating, this x is equal to by, you are getting this dx is equal to b dy by plus y dv. So differential equation becomes, substitute these things in place of, if x is equal to vy, then v is equal to y upon x, sorry, x upon y. So in place of x upon y, you have to put v, and in place of v dx, you have to put b dy plus y dv. Okay, so after substituting, what you are getting, this, and then this bring to this in the variable separable form. So after when you are getting this equation, just bring it into variable separable form, then integrate it. So after integrating, what you will get, this equation I am getting. So after getting this equation, just put or just replace v is equal to x by y. After replacing, what you are getting, that is the solution. Clear to everyone? You can try also. This is your solution. You can try also in your copy. Okay. So equation reducible to homogeneous equation. So how previously we have learned, that is the equation reducible to variable separable form, but here equation reducible to homogeneous form. So how we can reduce to homogeneous if it is not in the homogeneous form? Then if the equation is like this, given as like this, so can be reduced to homogeneous form by changing the variable x, y to u, v also. So put x is equal to u plus h and y is equal to v plus k. Here h and k are constants to be chosen so as to make the given equation as homogeneous. Okay, so dy by dx is equal to dv upon dy. Okay, so by if we integrate, differentiate it, what we will get? Dy by dx is equal to dv by du. Okay, so the equation this becomes now dy by dx becomes dv by du, and after putting x is equal to u plus h, v plus k, y is equal to v plus k, you will get this. Let h and k chosen so as to satisfy the equation. Okay, so here you are getting this. Solve for h and k both 1 and 2 relation, equation 1 and 2. After solving, you are getting this. Now it becomes a homogeneous equation and can be solved by substituting v is equal to ut. Okay, so let's see an example for this. What we have to do, first you have to put x is equal to v plus s and y is equal to v plus k, and dy by dx is equal to dv upon du put karo. So after putting, you will get this type of equation, and then solve for h and k. Okay, so then after solving, what we will get, integrate it. Oh, it's in the homogeneous form now. So after getting homogeneous equation, or after reducing to homogeneous equation, then you can use the previous method, that is b is equal to ut. Let's see an example to understand. And for these questions, I'm giving 1 minute also. Let's try it. New time starts now. Okay, it's time. Anyone got the answer? You can share your answer in the chat box also. So see the solution. What is the solution? First, we are putting 2x plus 3y, 2x plus 3y as u, because it is not in the form of homogeneous. So we have to bring it into homogeneous equation. Then if you differentiate it, what you will get? Dy by dx is equal to 2 plus 3 dy by dx. You will get this. Now, this becomes 1 by 3. Oh, isko simplify karo, you are getting u minus 1. So after putting this 1 by 3 dy by dx is equal to 1 by 3 into dy by dx minus 2. Okay, so after putting this in place of dy by dx and in place of 2x plus 3y, we are putting u. So u minus 1 upon 2u minus 5. U minus 1 upon 2u minus 5. Okay, so this you are getting. Then what is happening? So dy by du by dx becomes, take all the simplifications, do the simplifications. You'll get 3u minus 3 plus 4u minus 10, 2u minus 5. So this becomes 3u plus 4u is 7u minus 13 upon 2u minus 5. Okay, so if you'll cross multiply it, what you will get? 2u minus 5 upon 7u minus 13 dx and integration of dx. So after integrating, what you will get? This is easily happen. Okay, after integrating, what you will get? This, and after simplification, you are getting this. So in place of u also, you have to replace 2x plus 3y. Okay, so if a2 b1, then simplify, simply cross multiply. Okay, in this case you can cross multiply, simple hai na. Then you have to cross multiply. If it is not integrable easily, then check, use the homogeneous method by substituting this. Okay, if it is in this type of form, then you can easily integrate it, but it is not, then y is equal to vx put and then solve it. Okay, okay, so for you also, you have a concept test and take it as your homework question. You can take a screenshot of these questions also. Okay, and also these are some homework questions you have. You can take a screenshot. Okay, guys, so that's all for today's class. We have learned actually how to define order, degree, and also we learned a variable separable method, reducible variable separable method, homogeneous and reducible homogeneous method. Okay, so all these things we have covered in this session. Okay, so it's time to end your class now. Thank you all. Chalo, bye bye. Take care.